All right, guys, we are on to the holes option. In this particular exercise, we're going to look at the holes feature, which is a three-dimensional feature. We're going to learn how to make different types of holes. So there are a number of different types of holes. There is just a straight equal hole that goes all the way through. There are holes that are called countersink and counterbore, which means that at the top of the hole, there is space for the screw or bolt head to be flush below the surface of an object. There are threaded holes, and then there are clearance holes. And a clearance hole means that something else, say like a peg, is going to fit in that hole, and we want to make sure that the hole is large enough so that a peg with a certain degree of variability can fit in there. So in this particular case, we're going to apply 5 different holes to our disc here. Now I want to talk briefly about some of the annotations on holes and what they mean. First off, let's start right here with this diameter. Remember that the circle with the slash through it means diameter of 0.25 through. The through means that the hole is going all the way through the object. This particular instance is just a straight equal hole that's going all the way through. Very, very basic. We'll go over to the next one here. And you can see that there are 3 different measurements on this one. This is what we call a countersunk hole, which means that it is larger at the top and then it gets narrower for the rest of the bolt to go through. So the 0.375 through is referring to the entire hole that's going all the way through our object. This diameter of 0.75 is referring to the larger section at the top. So if we look right here, I'm going to zoom in a second, guys. Right here, this is showing the countersunk hole. This area right here is larger, and then this area right here is going to be narrower. So if we have a bolt, and you guys have all seen a bolt, which has a large head on the end, it can sit below the surface of our material, but it needs to have a larger opening. So this one is making that. And then this little arrow here means how far down this larger depth goes. When we actually make the holes, it'll be a little bit easier for you to understand. This one down here is very similar to the counter bore. This is called a countersink, and it means that instead of having a square bolt head, we have a screw that has an angle on it. And this is telling us that it's got an angle. This is the diameter of the top of this hole, and then the angle of that hole. And then this is the overall center width. And then over here, I'll talk about this when we get to it, and then we're back to another fairly basic hole. So we're going to walk through each one, and I'll talk at them in a little bit of detail on each one. So first thing we need to do, as usual, is we need to get a new part started. And I'm going to kind of flip back and forth here. We can see that we are making a disc of 4 inches in diameter with a 1.5 inch extrusion depth. So let's just go ahead and do that. And for the sake of simplicity, I'm actually not going to put this on my origin point. It'll make it a little easier for you guys to see. I want to get this all the way away from these lines. All right. And now we're going to extrude that to a depth of 1.5. Hit OK. And bring that back into place. So we have our disc that we're going to start putting holes into. I need to start a new sketch on that surface. And of course it moved the lines for me. I'm going to go ahead and project my geometry. And now let's look at what we need to accomplish here. So we have a bunch of holes that are along a nice perfectly round circle that is at a specific distance away from the edge. So if I look here, it is telling me that this circle where all of my holes are placed is 2.5 in diameter. So I'm going to add a construction line. That way I can save myself a little bit of work. So I chose circle, I chose construction line, and I'm going to make it 2.5. So now I know all my holes are going to be placed on this particular construction line circle. I'm going to turn construction line off. I'm going to introduce you to a new feature called points. We're going to be using points to make points where we're going to place our holes. This is how the hole tool works. It needs to know where to put them. You have to put a point in first. Now there are 2 different types of points. I'm going to show them to you. I can do this point, which is a center mark point, which has the dashed crosses, or if I click on this button right here, center point, and change it, uncheck it, when I put another type of point in, I just get a dot. For the sake of our whole features, we want to use this dot feature. So I'm going to delete these because I don't need them. So make sure that this button right here, this center mark or center point button, is not highlighted, so it's not blue. Choose point, and we are going to put our first point along our 2.5 construction line, dead center along our origin axis there. All right, so we have a point right there. You can see it. Now we need to do 4 more along this equally spaced. So we're going to use our circular patterning tool. We're going to choose our point. I'm sorry, I guess I didn't choose it. We're going to choose our point. And then we're going to choose axis. So go ahead and hit that. And I just always go with the center mark. All right. And now you can see that it's got an arrow telling me it's going to go around in a circular pattern. We're only wanting 5. I do want it to go a full 360 degrees, meaning the entire circle. Go ahead and hit OK. And before you hit OK, you can see right here, there's a yellow dot, there's a yellow dot, there's another one, there's another one. These are the 5 points that we're putting into place. All right. So now, again, I'm going to center this a little bit. You can see the 5 points that we've put into place in which we're going to place our holes. So go ahead and finish the sketch. And then flatten that back out. I'm going to zoom in a little bit. I'm going to zoom in a little bit more. So we are going to be putting holes here and here and there and there and there. So let's look and see what kind of holes we need. Right now, the top one is a 25 or 0.25 diameter through hole. This one's very easy, but we're going to be using the hole tool. I know I haven't told you guys how to use this yet. I've told you to avoid it. Now we're going to play with it. So choose the hole tool. All right, let's move this over here. And I need to tell it what point I want to base my hole off of. So I'm going to choose that. And now we go into all of these features that we have. We're going to start out with our basic straight hole right here. I'm going to change my termination to through all because according to our diagram, it said it's supposed to go all the way through. And right here, I set my diameter at 0.25 inches. So I can hit the green check mark here, or I can hit OK. I'm just going to go with the green check mark. And now we have a 25 or 0.25 inch diameter hole that's going all the way through. You see, it's just a basic hole, nothing special. We're ready to go on to the other ones. But you might notice that all of the points that we put in are now gone. And this is a bit of a problem. How are we going to use them if we can't see them? They're still there. They're just being used up by this sketch. So what we're going to do is go under our hole tool, expand it out so you can see sketch 2. And if I hover over sketch 2, you can see there's our construction line and there's all our hole points. I would like for you to right click on sketch 2 and we're going to use share sketch. All right, now we can see all of those hole points again and we can make use of them. So we've shared that sketch. All right, let's look at our diagram again. Our next hole is a counterbore. And we are going to be making a larger hole at the top with a smaller hole in the bottom with a couple of different dimensions. So I'm going to slide this over here. Let's do another hole tool. And we're going to choose this hole. Now you can look at some of the options right here. This one is a straight hole. This is a countersunk and counterbore, and this is a countersunk. So we're going to choose this one right there. So go ahead and choose counterbore right here. And you can see this is what I was describing. The hole is T in shape. The top section is larger to allow for the head of the bolt, and then the part that runs all the way through is narrower to allow for the threaded portion of your bolt. So in our diagram, it said that, and I'll show it to you guys again here. It said that the excuse me, the through diameter is 0.375. The counterbore is 0.75 with a depth of 1/4 of an inch. So you can see all of this information is being asked of us right here. So the through diameter is this diameter down here. So let's go ahead and change that to 0.375. Okay. And then our counterbore diameter, which is this larger section of the hole, is 0.75. and it went to a depth of 0.25. So we're making this T-shape hole right there. And you can see how on your sketch it's got like a larger circle and a smaller circle. It's showing you that there are two different size holes in there. Go ahead and click OK. And now if I tilt like that, you can see this section right here is only a 1/4 of an inch deep, but it's wider than this section in the middle. Great. All right, let's do the next one. Hole tool again. We're going to choose on the third. And on this one, we are making a countersunk. Now, countersunk is for a wood screw. This is a screw that the head has a angled V shape on the bottom of it. I'll show you some of these next class. And again, we've got two different size holes. This one also has an angle. So we're going to choose back in Inventor this option right here, which is the countersunk. So we choose that, and you can see what I mean by it's got that V shape. It's on an angle. Let's see, PLTW wants us to make this a 0.375 through with the countersunk diameter of 0.75 and a degree of 82 degrees. I've already got mine set because I did this a little while ago, but this is the diameter for the larger hole. This is the angle for this angle head right here, and then this one is the diameter for the longer hole for the threaded portion of your screw. So go ahead and click apply or check, whichever one you want, and you're good to go. Again, if we look at our hole here, we can see how this one has a bit of an angle, whereas this one is a straight 90 degrees. All right, one more hole, choose here. This one's a little bit more interesting. It's got some more information. It's called 1/4-20 UNC-1B with a depth of 0.75. This 1/4 UNC-20 UNC, it is a specific universal size fastener that is used worldwide. So everybody will use it. It's referring to the number of screws on the, the number of twists on the screw, the exact size of the screw. So it's very, very universal. So we are going to go over here and we're going to use some of these down here. We are making a tapped hole. A tapped hole is having a specific number of threads along a shaft that's going to match up to the fastener that we're going to put into it. Now, when you first click on this, it's going to take a moment. You can see how on my computer it's nothing's coming up yet. This takes anywhere from 30 seconds to a couple of minutes to spool up. Be patient. I'm going to pause until it comes up. All right, it came up as soon as I paused. When it's finally selected, you get all of these extra options. So you can see it's the ANSI Unified Screw Threads. ANSI is the American National Standards Institute or Unified Standards Institute. Basically, it's saying it's an organization that sets rules that everyone will follow in reference to, in this case, measurements. So we're all using the same unit of measure and the same size. When we say something is a 1/4 of an inch, it actually is. So our PLTW is asking us to have the 1/4-20 UNC. So we're going to look right here. We're going to change our size to 1/4, which is 0.25, and that'll change the designation to 1/4-20 UNC. And if you want to change it, you can choose a different one. It also is asking us to have it be 1B and then a depth of a 1/4 of an inch. So we're going to change our class to 1B. And then we need to change our depth over here to termination to distance instead of all. And we put in our distance of 0.75. The last thing we need to do is, this is not a countersunk, this is a straight hole, so we just need to change that to straight hole, and we are ready to go. Oops, actually I need to choose the whole place before I can have it work. Go ahead and hit OK. And now we've got a not all the way through, because we didn't want it to go all the way through, threaded hole. So if I scroll way in, it's really hard to see, but there you go. You can see that there's a little bit of threading on the hole there. All right, we have one last hole to do.